Module 3. Today we are starting Module 3. Okay, we just went over on the team websites the overview of Module 3, what we anticipate. If we need to change it along the way, we change it along the way. But the outline is posted on the website so you have an idea of where we're headed. Module 3 is rational numbers. I'm hoping most of this unit will be a solid review from elementary school. It's pretty straightforward. So we're going to go kind of quickly. If we need help along the way, we'll stop and do some extra help along the way, okay? Today we're actually going to be looking at lessons 1 and 2. To make up some time to make sure we have the whole curriculum covered by the state assessments, I looked at the lessons and I realized lesson 1 and 2, we could get them both covered in one lesson. So lesson 1 is positive and negative numbers on the number line, opposite direction and value. And lesson 2 is real world positive and negative numbers at 0. Okay, so that's what we're going to look at today. First, we're just going to talk about integers a little bit. We're not working in our new packets yet. The set of whole numbers and their opposites, including 0, are called integers. A number line diagram shows integers listed in increasing order from left to right using equal spaces. Sometimes those spaces are called intervals. This should sound very familiar from your measurement unit in science. You looked at those intervals and those spaces on the graduated cylinder, triple beam balance, your thermometer. Remember when you did all this back in September, October in science? This should all sound very familiar from that. As we move from left to right, the numbers increase. Okay, so here we have -9. As we go up to -8, it's actually increasing. So -8 is larger than -9. Okay? Starting at 0, as I move further to the left of 0 on a horizontal number line, the values get smaller. So anything to the left of 0 is less than 0. So negative numbers are any numbers less than 0. Now notice the curved arrow is pointing to the left to show a negative direction. The position of the point is now -3, which is written as that little subtraction sign and then the 3, and that's read as -3. Now this is a horizontal number line. You could also see a vertical number line. On a vertical line, the positive numbers are located above 0, and the negative numbers are listed below 0. And we see this on a thermometer. Temperatures today, this morning I woke up with the wind chill, it was below 0. It was cold outside, okay? Well, the shampoo and conditioner in my gym bag was frozen. Burr. All right. So this is a vertical line, and as we move up, the numbers increase. As we go down, the numbers decrease. So far, so good? You got this. No problem. Now, let's take a look at this number line, which we've already looked at twice. Look at -3 and +3. Is there some sort of relationship or something that they have in common or the same, those 2 points on that number line? What can we say about those? They are both 3. What does that 3 represent, though? Because they have different values. I would much rather have 3 cookies than -3 cookies. So you said about the 3. What does that 3 represent? Either 3. Why 3 what? What does that 3 mean? Uh-huh. What does it mean?
And -3 means it's not 0, it's 3 under 0.
Okay, 3 less than 0, and the other one is 3 more than 0. Exactly. That's the exact answer I was looking for. You two are close. They're both 3 spaces away from 0. 3 units away from 0. 3 intervals away from 0. So they're both the same distance from 0, right here. So because -3 and 3 are both the same distance from 0, we can call them opposites. It's on the board in red, bold, and underlined. Okay? And 0 is its own opposite. So the opposite of 0 is 0. Yep. So far, so good. Any questions on this?
Yeah.
What?
Number line, like, why wouldn't it go up to like instead of starting from like, wait, actually that was.
Well, number lines, we can start wherever we want. That was a good question because it's going to lead us into our next slide. So here's a blank number line, and if we wanted to show 150 on that number line, we have lots of different options. Are there 150 tags on that? No. So I cannot go from 0, 1, 2. That's not going to work. What could I do instead? Sure, 0, 10, 20, 30, until I get all the way up to 150. Could I do this? Could I do 0, 50, 100, 150? Could I use intervals of 50? Sure. Yeah, as long as all the intervals are the same. Okay, as long as I don't go from 10s to 5s to 50s all on the same number line. As long as they're the same all the way down. Could I start it over here? Could I start my number line there? Sure I can. Absolutely. Please stop playing with the tabs. They're distracting you and I'd rather you be paying attention to the lesson. So because the arrow's on the end of the number line, that shows it keeps going in both directions. So we can actually slide our numbers up and down and start our number line however we want. Okay, and that's something we're going to practice. We're actually going to start today in your notes on lesson 2. So turn to lesson 2. And this is example 1 on page 4. So everybody, please turn to page 4 in your packet and lesson 2. Let's look at this real-world example of how integers play a part in our lives every day. Because they do. Why do we have to learn this? Well, you do have to learn this because this is a real-life situation. We use integers more than you realize. So Tim just had his 13th birthday, and he received $150 in cash from his mom. His dad took him to the bank to open a savings account. Tim gave the cash to the banker to deposit into the account. The banker credited Tim's new account $150 and gave Tim a receipt. 1 week later, Tim deposited another $25 he had earned as allowance. The next month, Tim had asked his dad for permission to withdraw $35 to buy a new video game. Tim's dad explained that the bank would charge $5 for each withdrawal from the savings account and that each withdrawal and charge results in a debit to the account. Blah, blah, blah. It's a lot of stuff there. We're going to break it down one line at a time and see what it all means. So if I had a bank account, I'm going to open it. I go to the bank. Right now, my bank account has no money in it. So how would I write that integer, a bank account with $0? What integer would I write to represent that?
Like 0.
0. That's right, you can put that on your notes. So let's draw a number line that shows 0. You have lots of different choices of types of number lines that you can draw. If you want to draw one that's a little simpler, you can just draw that. It's a little simpler. Right, as long as you're putting the plot above the 0 on the number line that you choose to draw. All right? So now, Tim is going to make a deposit of $150. What type of integer would that be? If he's adding $150 to increase the amount in his account, he's putting $150 into his account. He's adding it into his account. So now he's going to have more money in his account. So what would that be? Right, that would be a positive 150. When you're writing positive numbers, you don't have to write the positive sign. But when we're working on our integers unit, I normally encourage you to write the positive sign just so that you know you didn't forget to put a negative sign, right? Because when I hand back your test, do I put positive 87? No, I write 87, okay? But for now, we're just going to put positive so that you know you didn't forget to put the negative symbol. You can draw any type of number line that you like, even like the ones from our first example. Now, gave the cashier the $150. She decided to credit to his account. A credit of $150. How would we write that as an integer? Okay, you know what, you would hear this sometimes. How many of you got something for Christmas and you had to return it? Yeah. My son got a sweatshirt and it came in the mail and it was actually dirty. It showed up. The white sweatshirt had a dirt mark on it. So I called the company and they said, all right, we'll send you a new one. Send us the dirty sweatshirt, and when we get it, we will credit your account the $56 for the sweatshirt, okay? So I sent it back to them and they credited my account the money. So if they credited my account, did they add money to my account or did they take money away from me? Yeah, they gave me money. They added that money to my account. So when you see the word credit, that's a positive number. Okay, they're crediting your account. You go out to dinner and your burger is just still raw. It's disgusting. It's still mooing. You decide you can't eat your dinner. So they go back to your check and they go, all right, tell you what, we'll credit you for your burger. We're not going to charge you for it. So now they're adding that back onto the bill instead of you paying them. That you don't have to pay them that. Okay? You make a deposit of $25 in your account. How would you write that as an integer?
Negative 25.
You're making a deposit. You're adding money to your account. Exactly. Plus 25. You could draw, there's so many different types of number lines that you can draw for this. You don't have to draw the ones that you see here. Now the bank is going to charge you $5 for making a withdrawal. So the bank is going to charge you, they're going to take away $5. So how would you write that as an integer?
-5.
Very good. -5. And there's different ways, different types of number lines that you can draw for that. Yeah, you can start your number line at any number. 0 does not have to be in the middle. It does not have to be even on both sides. Nope, lots of flexibility making number lines. Keep it simple. Keep it simple. If you're taking $35 out of your account, okay, you had $100, you're taking out 35. You're taking it away. -35. Again, this time they put it all the way on the left, but you can plot it on any type of number line that you like. We need a second to catch up? Okay, let's continue. Another example of where we would see integers in our daily life or the real world. Now we hear about it all the time. Polar vortex, we're freezing. Don't sneeze, your eyes will freeze shut. Crazy nonsense outside. So, I don't know, it's hot in here. I can't think straight. My brain is melting like my chocolate. Okay, so how hot, how cold? Temperature is commonly measured using one of two scales, Celsius and Fahrenheit. In the United States, the Fahrenheit system continues to be the accepted standard for non-scientific use. All other countries have adopted Celsius as the primary scale in use. The thermometer shows how both scales are related. So let's take a look at this thermometer. The boiling point of water is 100 degrees Celsius. Where is 100 degrees Celsius located on this thermometer to the right? Where is it? Uh-oh, where is it? Where is it? Where is it? Where is it? Why isn't it there? Celsius side only goes up to 50 degrees Celsius. We don't have the 100 degrees Celsius on that thermometer. Okay? You're writing this down in your notes. We're on page 5. On a vertical number line, describe the position of the integer that represents 100 degrees Celsius. So on vertical, which means going up and down, where would we find 100 degrees?
At the end, so
Well, it doesn't have to be at the end. Because we just drew number lines and we could put them wherever we want. Where would it be? After what? Well, what is usually consider like the starting point sometimes? What would we consider the starting point? 0. So on a vertical number line, we usually would look for 0. Where would we find 100? Right, after where? Above or below? Above. 100 spaces or units above 0. It has to be above because that's what makes it positive. If it was below 0, it would be negative. Right? We're hearing a lot of that with the wind chills now. With the wind chill temperatures, we're hearing below 0. With the real feel. With the polar vortex. All right. The temperature shown to the right in degrees Fahrenheit. So here, the temperature on the thermometer, what is it in degrees Fahrenheit? 100 degrees Fahrenheit. What is it in Celsius? What does that thermometer read in Celsius? 48? It's below 40. Not past the 40, it's below the 40.
39.
I think mine is blown up bigger so it's easier to see. It looks like it's about 38 degrees Celsius. Okay? What is the freezing point of water in Celsius? Here, what is the freezing point in Celsius? Everybody? 0 degrees Celsius. I think that was kind of a silly question. All right, if somebody said that your body temperature was 98.6, would that be in Fahrenheit or Celsius? Fahrenheit. Well, we know from up here the boiling point of water is 100 degrees Celsius. Okay? Okay. So it would, I'm sorry for the interruption if you're watching the vlog at home. So 98.6 degrees Fahrenheit. We know that it would be Fahrenheit because 100 degrees Celsius is when water boils. So our blood would be boiling if we were at 98.6 degrees Celsius, right? Yes? Yeah, that too. Okay? But I'm just going to blood, water, liquid, even though it's plasma. Stop being so smart! All right? Does the temperature 0 degrees mean the same thing on both scales? Does 0 mean the same thing? Well, here is 0 on Celsius, and here's 0 on Fahrenheit. Do they mean the same thing on both scales? No, absolutely not. Let's take a peek, because 0 degrees Celsius equals 32 degrees Fahrenheit. That's not the same thing, right? 0 degrees Fahrenheit equals negative 18 degrees Celsius. So they do not mean the same thing. Okay, any questions so far? let's review some of the words that we've been talking about that help us identify whether it's a positive or negative number. So gain, is that positive or negative?
Positive.
Deposit,
Positive.
loss,
Negative.
charge. Huh. If they're going to charge me $5 to park my car, that's negative. They're taking it away from me. Withdrawal, receive, credit, positive. Remember, they're going to credit my account. They're going to give me my money back when I make my return. Debit, negative. A debit card. I bet all your parents have a debit card where they're withdrawing money from their account. They're taking it out, their balance. Below zero, negative. If you owe me money, negative. All right, so those are some key words that would give you information on whether it's a positive or a negative number. Try number 4 on your own. Try number 4. Fill in those integers, positive or negative numbers. All right, let's go over and see what they are. A company loses $345,000. What would that be as an integer? Hold on. Thank you. Right. You earn $25 for dog sitting. Very good. You owe your dad $5.
Minus $5.
Say negative $5. Yep. The temperature at the sun's surface and in this classroom is about 5,600 degrees Celsius. What's that as an integer? Let's get more people raising their hands. It's the same people over and over, and I appreciate the participation, but I want more people involved. Right. Now again, normally we would not write the positive sign, but since we're in our integers unit, we will. 4 degrees below 0. Yup. A football player lost 10 yards when he was tackled. Yes, Jet sweatshirt. Ha 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 ha. Sorry. Yeah. All right. A situation that would be negative 15. You owe your friend $15. But what would the 0 represent? 0 would be when I don't owe any money. Okay, so 0 would be like we're even, Steven. I don't owe you money. You don't owe me money. Everything is balanced. We don't owe anybody money. Yeah, even Steven. Okay? So one more quick question in our closing before I explain exactly what you need to do for your homework. Can a temperature of negative 9 degrees be described as negative 9 degrees below 0? Can we say that? No, we're saying it twice. It's either negative 9 or it's 9 below 0. That's like saying it's cold. Okay, you're not going to say it twice, all right? So I'm going to stop the recording. I want everybody to turn to problem set for lesson 1.